Hi guys, this is Mr. A again with another physics solved problem. This question is about uh, rocket motion and how rockets change the velocity of spacecraft. So let me go ahead and read the question to you. Small rockets are used to make small adjustments in the speed of satellites. One such rocket has a thrust of 14 newtons. If it is fired to change the velocity of a 304.7 kilogram spacecraft, by 34.2 centimeters per second, how long should it be fired? Okay, so we're looking for how long the rocket should be uh, kept on to make this velocity change. And something that I want you to note here is, let me make a mark on it. This 34.2 is in a unit that is meters per centimeters per second. So that is something that is important to note. Let me get rid of this thing here. Um, so that's the part that I want to point out here, that the speed of or the velocity is given in centimeters per second. And that is an important thing to note, and we will deal with it in just a moment. But let's go ahead and list all the information. First piece of the information is that we are required to find time. So that is listed here, and when we find time, it's going to be in seconds because in all known uh, standard units, the unit of time is seconds. The second part or the next part is what's given. And what's given to us is this. We have a mass of the spacecraft, and we're going to denote it by m, and it's given as 304.7 kilograms. And then they are giving us the force or the thrust that the rocket produces, and we're going to give that by or use a symbol F for that, and it's 14 newtons. The next part is the change in velocity that we were harping about a second ago, that the change in velocity of 34.2 is given in centimeters per second. Now, the first thing we want to do here is to make sure that the units are consistent. What do we mean by consistent units? Simply that all units that we are dealing with should be in the same system. You are aware of the systems of units, the CGS system, the MTS system, the FPS system, and the most relevant, which is the SI system of units. So as long as you understand that all units should be consistent, meaning all should be in the same system. So here we look at these units and we see kilograms for mass and newtons for force. So, and we know that both of those are SI units. Centimeters per second, however, is a CGS unit. Since we have an answer that could be in any units really, because seconds are part of all the systems. So rather than changing two units, it's easier to change just one, and that's what I propose we do. You can always change those other two units and solve your answer in CGS and still get the same answer in seconds. But like I said, it's much easier to deal with SI units anyway. Okay, so how do we convert those units? There are several ways, and today I'm going to show you how to do it using dimensional analysis, and we will probably talk about that briefly so that you know how to do it. So we're in a way solving two problems in one. Okay, so here is what we have. What we are looking for is to convert centimeters per second to SI units, and we know that SI units are meters per second. So the first thing we do on the very left-hand side of our equation, we write down what we are looking for, and that is meters per second. Good. And then that is equal to the given 34.2 centimeters per second. So we write it like that. And in this case, we're not going to bother with the seconds because eventually the seconds are not changing. It's just the centimeters changing to meters. And so next step is then to multiply by a fraction such that we can cancel out centimeters from it. There. Okay. Um, yeah, my marks for crossing those systems out was overlapped, and so it moved off. That's fine. We got it back to where it's supposed to be. So we have 34.2 centimeters per second. That is given to us. That is the velocity change that we are looking for, delta v. And the factor that is going to make that change is the relationship between meters and centimeters. And you know that there are 100 centimeters in 1 meter, so you have 1 meter over 100 centimeters. Now, the question, why is it not 100 centimeters over meters? Well, the simple answer is we want to get rid of centimeters from this statement. And so we want to write it so that these centimeters will cancel out with these centimeters. And that's the simple reason for writing it like that. If we were converting meters per second to centimeters per second, then we would write it the other way around so that we would cancel meters out and leave centimeters there. So, whatever you don't want is how you arrange it so that you can cancel to each step. And sometimes you have to do several steps to get this. But in this case, we just need that one step. And once that's resolved, what we have on top is 34.2 times 1 meter, which we have written right here. And then at the bottom, we have seconds times 100. And so we have 100 times seconds. This centimeter is crossed off, and this centimeter is crossed off. So it becomes a 1 here and a 1 here. And we don't really bother with multiplying by 1 in those cases. Even in this situation, I've just written the 1 meter, but we're not going to really be able to do anything with the 1. When you multiply it by 1, you just get the same number. And I'm sure you're all aware of that. Okay, so going on to the next part, we multiply this, divide by 100, and we get a 0.034 because the decimal place, oh, no, I'm sorry, let me correct. No, it's not that. So it's going to be 0.342 because the decimal is going to move only 2 spots to the left. And that will affect our calculation at the end. So I'm going to make that change also. But not to worry because it's, we got it early, so we'll fix it. Let me go ahead and pull up the calculator. And we have, what do we have here? Let's see, it's 307.4 times 0.342 divided by 14, and that comes out to 7.51. 7.51 seconds. And we will look at the significant figures in just a moment. Let's just put it like that. Okay, so that's, let me go ahead and explain the rest of it. So that's just the dimensional analysis, which is just only used for converting units. So we converted the unit, and there we are. Now, we know that from Newton's second law of motion, we have F equals to ma. And I'm sorry, I misspoke. It's even though it's popularly known as Newton's second law of motion, it's actually really Newton's second law of force. First law has to do with one force. Oh, sorry, first law has to do with no force. Second law has to do with one force, and third law has to do with two forces. So this is the second law where we say that force equals to mass times acceleration. And we also know that acceleration is the change in velocity divided by change in time. Okay, so using this equation, we plug in the numbers. F is 14, m is 307.4, and then delta v is 0.342, and delta t is what we're looking for. So that is our only unknown variable. And then we rearrange so that we have delta t equals 307.4 times 0.342 divided by 14. And that comes out to 7.51 seconds. So that is the time taken or the time or the duration for which the rocket should be turned on to cause the change in velocity as desired. Okay, now we want to pay attention to significant digits, and significant digits are determined by the least accurate of the values we have. We try and go back to the data before we've done anything to it just to make sure that the numbers we have are good. And this one has four significant digits. This one has two. This one has three. And then after we converted units, we kept the three significant digits, so that's fine. But the significant digits of the least accurate are two, which is the fourth. So two significant digits, which means that we will remove the one from here, and our correct answer would be 7.5 seconds. Okay, guys, that about sums it up. If there is any part that is not clear, or you need, you know, you have a different question that you want me to make a video on, please go ahead and let me know. You can get to my email through Wizened, and you can get to my email through YouTube. So either way, you can get in touch with me. And I have a little message for everyone right here. And so please pay attention to that. I am available for one-to-one tutoring for IB and AP physics and high school physics, and even high school and middle school math. So if you or anybody you know needs some help, please feel free to get in touch with me. And that is all for today. So this is Mr. A signing off.